Good evening everyone. Today we are going to discuss Owen's bridge. This measures the inductance in terms of capacitance value. So let's divide this. We will be discussing in three ways. First, circuit diagram, next phasor diagram, next bridge balancing condition and Q value. Now this is current I1 flowing here. At bridge balance the same current will flow here. This current is I2. As this current is 0, the full current I2 is flowing here as I2 entering, and the same I will be coming out. Then this will be the E1 and this will be E2 E3 sorry. This voltage will be E2 and this voltage will be E4. For this phasor diagram, let's take reference as I1. So first drop we see is R1. I1 R1 is the drop across this resistor, and I1 J omega L1 is the drop due to this inductor. This will be the resultant E, that is E1. Now in the same branch there is another resistor R3. Let's consider R3 drop across is I3 R3, that is E3. This is the E3 drop. So this E3 drop is equals to E4 drop. That means the current is in this is I2 into 1 by J omega C4. So the drop due to this capacitor is in phase with I1. Then the current I2 is in the capacitance effect. So the resistor drop, the capacitor current will be leading the voltage drop. So let's take this is I2. The drop across I2 is, first drop is I2 R2. I2 R2 is the drop across first. Then we can say another drop is capacitive drop. So it will be perpendicular to the resistive drop. Then it will be written as I2 1 by J omega C2. Then this will equals to E1 E2. Here is the voltage drop, that is E3 is equal to E4. Now this is called as resultant voltage E. Now bridge balance condition. At a balanced condition, Z1 Z4 equal to Z3 and Z2. So Z1 is here, that is R1 plus J omega L1, and Z4 will be 1 by J omega C4, and R3 will be R2 plus 1 by J omega C2 R3. This is the equation. From this equation we need to find R1 and L1. So for this we will writing R1 and J omega L1 here, and remaining terms that side, that is J omega C4. This R3 is multiplied inside, that is R2 R3 plus r3 j omega c2, and r1 plus j omega l1 is equal to, if we multiply this inside, that will be j omega c4 r2 r3 plus, if we multiply further, j omega cancelled, c4 r3 and c2. From this, comparing real and imaginary terms, that is real terms are r1 and this one, then r1 is equal to c4 r3 c2, l1 will be, imaginary terms are l1 is equal to c4 r2 r3. Here the q value will be omega l1 by r1. Omega l1 what we got is c4 r2 r3 divided by r1 is c4 r3 and it is c2. Now r3 or c4 will be cancelled out, then remaining will be omega c2 r2. This bridge gives wide range of measurement. If you want to find high Q value, then the C2 will be increased accordingly.